Hello, students. If you're watching this video, it means you've probably already watched the basic writing of Lewis dot structures video, which I went through 3 steps on how to draw the preferred Lewis structure. Now, that video was geared towards an introductory or preparatory chemistry where they didn't take into account formal charges or expansion of the octet. And that's what this video is going to introduce. So this video is going to help you determine what a formal charge is and how to use it to pick the preferred Lewis dot structure. So formal charge is the number of valence electrons for the central atom, and you can do it for any atom. You're looking at the number of their valence electrons, and you're subtracting the number of electrons in bonds, which is usually, right, 2 electrons in a bond, and then you divide that or multiply it by 1/2. So I just tell students, count the number of bonds rather than the number of electrons and dividing by 2. So it's the number of valence electrons minus the number of bonds minus the number of electrons in lone pairs. So let's start with an easy one. Let's do carbon. So we know that carbon has 4 valence electrons, right? But it wants an octet. It wants to be like neon, and that's why it forms 4 bonds. Okay, so if we follow these rules for determining formal charge of a carbon, right? So for this central atom, we'll say, well, how many valence electrons does it have? Well, it had 4. That's why we drew 4 dots, and that's because it's in group 4A. And then we're going to subtract the number of electrons in bonds divided by 2. I just say subtract the number of bonds. Well, we just said it has 1, 2, 3, 4 bonds. And we would subtract the number of electrons in lone pairs. Well, carbon doesn't have lone pairs, so we would make that 0. And then 4 minus 4 equals 0. So this carbon atom likes to have 4 bonds because it wants a formal charge of 0. Well, what about nitrogen and oxygen? It's pretty much the same thing, right? Take nitrogen. It's got 5 valence electrons, right? But it wants to have 8. It wants an octet. So it needs 3 more electrons. How does it do that? It forms 3 bonds, right? So you could think of a hydrogen donating a bond, an electron in that bond, 1 right here, 1 right here. So really there's these 8 electrons around this nitrogen, okay? So how do I figure out the formal charge for this nitrogen, okay? So for nitrogen, the formal charge, how many valence electrons? We already said 5, because it's in group 5A. How many bonds? Well, it likes to form 1, 2, 3, minus 3. Now, how many electrons in lone pairs? Where it had 1 lone pair and each lone pair has 2, minus 2 equals 0. So that's why nitrogen likes 3 bonds in 1 lone pair. That's why that's the preferred bonding pattern. We could do the same thing for oxygen, right? So oxygen, valence electrons is 6, but it likes to have an octet, so it forms 2 bonds. Now, for oxygen, what's the formal charge? 6, right? Minus 2 bonds, these are the number of bonds for my formal charge, right? The 6 is the number of valence electrons, minus 4. Where am I getting the minus 4? The number of electrons in lone pairs. So what does that give it? A 0 formal charge. That's why oxygen likes 2 bonds and 2 lone pairs. Now, it doesn't mean it always has 2 bonds and 2 lone pairs. And what do I mean? Let's look at carbonate. We saw that, right, in the Lewis dot structure video where, and I have resonance. Right, so right off the bat, we know this is carbonate. It has a 2 negative charge, okay? So if we look at what I just did, I know that this carbon's formal charge, because it has 4 bonds and 4 valence electrons, so it has 4 valence electrons and it has 1, 2, 3, 4 bonds. Again, they don't have to be 4 single. They can be 2 single and a double. This carbon's formal charge is 0, so it's super happy. I'm going to call this oxygen A. If I look at oxygen A, so oxygen A, I'm going to calculate the formal charge. It has 6 valence electrons. I'm going to subtract the number of bonds, 1, 2 bonds, minus the number of electrons in lone pairs, 2, 4. Just like this example here, the oxygen A has a formal charge of 0. Why? It has a preferred bonding pattern of 2 bonds and 2 lone pairs. Now these oxygens, we'll say they're the same for now. Oxygen B type, so I want to figure out the formal charge for the oxygens of the B type, right? So we're going to do the same thing. They have 6 valence electrons because they're in group 6A. Now how many bonds do they have? They have 1 bond, minus 1 bond, minus the number of electrons in lone pairs. So 2, 4, 6, 6 minus 1 minus 6, my formal charge is a negative 1. So these oxygens with a single bond have a formal charge of negative 1. Well, that makes sense because this species overall has a negative 2 charge. So that's how we can use formal charge in determining or use that formula to determine the formal charge of atoms in covalently bound either molecules or polyatomic ions. Stay tuned for the next video where we apply it to picking the preferred Lewis dot structure.